Hey, there, welcome back. So this is your Ramandeep Singh, and today we're going to be solving yet another LeetCode problem. And the problem name is this find bottom left tree value. So this problem is a simple one if you know how to calculate the depth of a particular node. You know? So like given any node of a binary tree, if you can find what is the depth of that particular node, then this problem becomes very easy for you. So let's read the problem statement. We haven't given the root of a binary tree and we have to return the leftmost value in the last row of the tree. So what is the row? Let's see. Let's take this example. Uh, this example is 1, 2. So we have this 1, 2, 3, 4, 5, 6, 7. Okay. We have 1, 2, 3, and here we have 4, 6, and then we have 7. So that's what we have here. Okay, so this is my binary tree, and I want to find the what I want to find. I want to find the we have to given the root of the binary tree. We have return the leftmost value in the last row of the tree. So this is your first row. This is your second row. This is your third row. This is your fourth row. And I want to find, so this is the last row, no? Bottommost row, and I want to find the leftmost value here, and the answer is explicit here. The answer is 7. What's the answer for this? Try to find it. This is your like row. This is your first row, no? Containing this node number 2. This is your second row. So this 1 is the answer because this is the leftmost node here. Cool, eh? So like how we can solve this problem, let's see. So if you can calculate how to find the depth of the tree, you can easily solve this problem. Let's see how. So let's create a depth variable. And the depth at this level is 0 at this particular node. Now since the depth is 0, so the depth of this level is 0. This is a surface level, I will say. Now I move to the left node. So basically I'm just performing a simple DFS traversal. The depth become 1 here. Depth is 1 here at this level. So this is, so all the nodes at this level should be at depth 1. Okay. Now I also keep a global variable. Let's call it max depth. And so like how deep we have gone so far. So at this point the max depth is 0. Once I visit this node, the max depth becomes 1. Now I move more further, like more deeper into this branch, and the depth here at this level becomes 2, and the max depth becomes 2 as well. Okay. Now I also keep one more variable. Let's call it left bottom value, है ना? Or call it the answer which I want. So what I want is left bottom, leftmost value in the last row of the tree. So I do not, so the uncertainty here is that I do not know, uh, like I have already solved this problem. That's why it may seem not so obvious to you, but actually it is obvious for me. Like if you have solved this depth related problems, then it becomes so obvious to you. So like what I want, I'm not like, no one is sure here which node is going to be the leftmost node. But I am sure that what I can do is I can always reach the deepest level. I can always reach the deepest level, and once I reach the deepest level, I can always find my answer. So here I have found depth 2. So let's also update the answer here. So at max depth, at depth 0, the answer is, let's say, 0, not 0, 1. I know this is the node. I have visited this level only. Now I move here. Now I move here. Let's update the answer as well. Update becomes, the answer becomes 2 here. Now I see a even deeper node and also the leftmost node. I found it to be 4. So the answer becomes 4. And now I come back and I move to this node. What is the depth of this node? I can see the depth stays 1. Depth is 1. Since the depth is 1, max depth also do not change. And since the max depth do not change, this answer also do not change. I move here. What is the depth of this node? It's 2. The depth is 2. And the depth is 2 because this is at the same row. Now, since the depth is 2, max step do not change, answer also do not change. So if I just had tree up to this point, this much binary tree, then I already have the answer. The answer is 4. And that's correct. This is the leftmost node in the deepest level or the deepest row of this binary tree. But now I go even deeper to this node. Now the depth variable changes. The depth variable becomes 3. The depth variable becomes 3. And here I update my max depth to be 3. And the answer is also updated to 7. Now I come back, and I come to this point. What is the depth here? The depth is 2. Will I update my max depth? No. Will I update my answer? No. So I'm done. So the answer I have extracted out of this particular example is 7 with the approach which I have. A simple DFS traversal with just 3 variables. So all I have to do is just create a DFS function which has a node thing, which has a depth variable. So this is a local variable. So it changes. Okay. So if node is none, I'm going to return right from here. If it is not, then I will check if the depth, the current depth, is greater than the max depth which I already have, the global one. Then the max depth will be updated with the depth, and the answer will also be updated. Let's say answer will be updated with this current node dot value. So once you have performed this process, once you have arrived at new level, then you are going to call this DFS for the left node first with depth plus 1, since there is a node, and then you will call node right with depth plus 1. That's all. That's how you will extract the answer right here. Cool. So it's a simple problem. If you know how to calculate the depth of a binary tree, then this problem becomes obvious with a little bit of critical thinking, and you are there. Okay, so let's just uh, jump to the code implementation part. Okay, so let's write this DFS function. We have node, and then we have depth. If node is none, then we will return. Otherwise, if depth is greater than, let's create a variable here, self dot max depth is equals to 0, not 0, minus depth is equals to 0, and then we also answer is equals to minus. So, okay. Then DFS root 0, and here we will return self dot answer. Okay. Self dot depth is greater than what? Self dot max depth, then depth is equals to depth, and answer is equals to otherwise self dot left, and also what else we can, depth plus 1. 2 मिनट आता हूँ, इधर मत So that's how we will perform DFS traversal over this node, and let's try to submit this if it works. Not right plus 1, depth plus 1. DFS is not self dot d, sorry. What? Self. Got it. So I got this answer and let's submit it. I got this accepted. Got these test cases. Let's see if it works. Got accepted. So that's all for this video. I hope so. This was just a TFS traversal with a little bit of critical thinking, and I hope you learned something out of it. I will see you soon in the next video. We'll learn about apart from DSA, we'll also start problem solving. Like I will also post videos and content related to system design. And hope to see you all in my next video.